Welcome, everybody, to the Tuesday, September 12th, 2017 meeting of Kubernetes SIG Service Catalog. So we're usually having Aaron do moderation today. Since he's not here, does anybody want to raise their hand to do that?
I'll do it if you want.
I expected Doug would volunteer, and I was not disappointed. So, Doug, you have the helm of the meeting, so to speak.
All right. Just a reminder: if you want to raise your hand, use the plus hand thingy in the chat, and go ahead and add your name to the list of attendees if you'd like to be on the official list. And let's see. First up, we have Sunil. You're going to do a demo of PodPreset.
Yes.
You want to share your screen?
Yeah. So let me. So let me know when you guys can see my screen.
It's a little small, but we can see it.
Yeah.
Just zoom a bit. Okay, so actually, yeah, should we dive into the demo directly, or should I go and explain how initializers work?
Why don't you do a conceptual overview of what we're looking at and initializers so that people can understand what they're seeing?
Okay.
Can you make the font just a little bit bigger?
Yeah.
There you go. Thank you very much.
Yeah, I will use this. Okay. So, yeah, so 2 months back, I started on this task of moving PodPresets to beta. And as part of deciding the roadmap, it was decided that PodPreset is one of the functionalities that should be developed as using initializers and should be developed outside the core. And so that's where this all started. So to give you an example, to give you a little bit of background about initializers. So in core Kubernetes, you have admission controllers, and admission controllers are, one second, I'll just, yeah, admission controllers basically gets executed before any resource, any object gets created in the system. And they are used to enforce policies like any admission control policy you want to apply. For example, it may be, let's say you want to enforce every pod that gets created should use the image policy should be always pull, things like that. The examples of pod security policies, and PodPreset was also implemented as in the alpha. It's actually implemented as an admission control plugin. So one of the disadvantages of admission control plugin is in the core is that they need to be compiled in the core, and they can be configured only at the API server startup time. So if you want to, let's say, extend the functionality, you want to, let's say, implement any other policy that you want to enforce as part of the object creation, then you want that to be built in the core, which is becoming harder and harder, as you can see. So that's where in 1.7 initializers were introduced. And what initializers are basically, you can pretty much think of them as that these are what initializers are. These are set of pending tasks that will get executed as a resource gets created in Kubernetes system. Till all these initializer tasks are finished, that's where we say when they are finished, that object is initialized, and then it will become active in the system. It would be visible to the rest of the system for it to act on. So for example, if let's say there is initializers configured on a pod and a pod request comes in, until all the initializers for the pods are executed, this pod will not become active in the system. So kubelet or any other component in the Kubernetes will not be able to act on it. It will not be even visible by default unless you specify a special parameter when you're querying pods saying, give me uninitialized pod as well. So any questions so far?
So initializers, oh, I'm sorry, Doug, go ahead. I violated the protocol.
No. I was going to say, I don't see any hands, but go ahead.
So initializers can actually perform admission-like rejection, right?
Yes. So the two things is what happened. Actually, let me show you an initializer configuration, and that will. How do I get this out? Okay. Yeah.
The reason I ask is because that capability wasn't actually part of the initial proposal for initializers, and I saw somewhere that had been added, which is
it is there. So what you're looking on the screen is right now initializer configuration, where I'm specifying that this initializer's name is podpreset.initializer.gates.io, and it needs to act on these objects. And objects are basically it's a GVK where you have API groups, you have API versions, you have pods. So you can create bunch of initializer configuration like this and submit it. Now, let's say there are two initializers which you have registered for pods. So as they get executed, they can mark the result in object metadata. So there are two fields that are introduced. One is in the object metadata, there is a field called initializers, which have list of pending tasks. And at the same time, there is something called result, which an initializer controller can write back. So the moment core API server sees that there is a result, which is basically you will write in case of a failure, it will reject the admission of that object. So I think it exists from 1.7 only. It's not new. So
Sunil, got a question for you. And this is more of a sort of a best practice kind of thing with initializers, and it came up recently. I assume you're familiar with Istio, right?
Yes, a little bit.
Okay, yeah. So question for you. So obviously, if you're deploying a pod and you want Istio to add a sidecar, then you're going to modify the pod spec to add the additional containers for the proxy stuff. And I understand that. But let's say you're actually deploying a deployment, as an example. Mm-hmm. Okay. Is it best practice to have the initializer modify the deployment so that inside the deployment where you define your containers, you add the Istio one? Or do you wait until the deployment itself deploys the pods and then you modify that pod? You understand what I'm saying? Yeah. So you're saying whether to write an initializer for deployments or whether to write an initializer for pod? Basically, yeah. Right. I guess it depends on the functionality where it belongs. So like in case of PodPreset, if we think, this is a functionality which belongs at the pod level, then you would write a pod initializer. And if it belongs at the deployment level, because see, if you are, let's say, writing for Istio and not every application deployed is using deployment. If it is, people are even deploying, let's say, pods, then those resources will not be initialized by your initializer. Yeah, no, I understand that if you wanted to hit everything, obviously the lowest level thing is the best thing. But I'm just wondering, if that isn't a concern to you, is it better to modify the person's? Because initializers are basically going to modify the user's the user's spec for them, right? Yeah. So the question is it better to modify the user's deployment, or is it better to modify the user's indirect pod, as a result of deployment? Yeah, while writing this, I realized that if you are writing a pod initializer, it is much more fundamental to Kubernetes system, and you can actually end up in a deadlock scenario. So let's say you have an initializer up and running, and it's a pod initializer, and somehow it got stuck, or let's say it is down, right? Now you pretty much lose your capability to launch any new pod in the system. It's even to launch the initializer controller itself, because it depends on pod initializers to be present. So
I think it's a very powerful mechanism, so it needs to be used with a lot more responsibility. You can only allow trusted initializers to be present. And some of the best practices, I think, are still, people are playing with it, so they have not come out that well yet. I think it needs more baking time.
Okay, thank you very much.
Yeah. So this is an example of an initializer configuration that we are looking here. So in this case, I'm saying that I want to intercept all pods, and this is my initializer's name. So this is how the linking happens. So this is very important. Now, once this initializer configuration is, let's say, submitted, and a new request for pod comes in, so the Kubernetes API server, it will look at the object, will see what initializer configurations are there. I mean, basically what initializer registrations are already there. It will in the object metadata, it will create a list of pending tasks for initializers, and one of them, and in the pending task, it will be the name of the initializer that needs to be executed. And then you have initializer controller on the other hand, which is listening for these objects that it is interested in, and it will see whether I can actually bring up my. I was thinking I can quickly show the example. So yeah, this is the code that I have as a controller, and in controller, what it is doing is it is listening for all pods, and it is looking at whether this pod needs initialization or not. And the way it is doing is it's looking at pod object metadata, it's fetching the initializers, seeing whether the first, whether in the, so if you look at initializers.pending, so this is the pending tasks. So it looks at whether I'm at the top of the queue. So this is PodPreset initializer name. If you look at this, matches with the one that we created in the initializer configuration. So if it's my turn to execute, then it says, okay, I need the initializer. This pod needs to be initialized, and then the logic for initialization is actually getting triggered here. So here you can see the admit function is executing the admission control logic, which is applying the pod preset in this case. And once it is done with applying the logic, which could be, let's say, mutating the pod spec, and then it can say that I'm done with it. So the process of saying I'm done with it is it will remove itself from the list of pending tasks. So here is how it is doing. If this was the only one in the list, then it will mark initializers object to nil. Otherwise, it is going to pop itself out and then initialize it to the rest of the. So if you think that there are multiple initializers, and they would cooperatively, they have to figure out whether it's their turn to execute, and they execute. Now bringing back to Paul's point, so let's say if admit fails here. Now, in case of failure, it can write the result of the failure. In our case, in pod preset, since it's not an enforcement policy, we don't reject if we fail to apply pod preset. If, let's say, it was a critical initializer and it was an enforcement plugin, then we would write the result back here, and then that would reject the admission of this object that we are trying to initialize. So another point I want to bring up here is this is critical to that was controller manager. Somehow my autocomplete is not working. So yeah. So how do you listen for uninitialized pods? So this is a quick example I wanted to show here. So
when you get a chance to know, we do have a hand up. Just let us know when.
Yeah. So this is, yeah, I'll just quickly finish this, then we can go to the question. So here, if you look at how I'm listening to the uninitialized pods, so there is a new option saying in the client Go library saying include uninitialized. So whenever you are listening or listing or watching any object, and when you're creating the shared informer, you can say include uninitialized to true. You will start receiving these uninitialized object. And everywhere else in the system, this is by default false. So that's why you don't get to see uninitialized object and system doesn't act on it. Okay, so now I'm ready to take the question. Let's see.
All right, Mr. Paul.
So I guess and this seems unlikely to me, but an initializer can only work on creates, right? Not updates?
It can only work on create, yes.
Yeah, that's what I thought. Okay, cool.
Okay, so now I can quickly jump into the demo. Demo is pretty much most of you guys have already seen probably PodPreset working in the core. So this time we'll see the demo using initializers. And okay, so let me. So what do you mean by non-create ops?
Well, you just said initializers only work on creates, right? And Paul mentioned updates. So anything but a create.
Oh, okay.
Yeah, I asked because the elevator pitch for initializers is that you can do admission outside of the API server, and this is not a criticism, and I can't imagine actually how to make it work. But one thing that you can do with admission controllers that you can't do with initializers right now is that you can reject an update and or mutate an object when it's being updated.
I see. Yeah. Got it. Yeah, because that path will not be covered by these. Yeah. I think that would probably come across after initializers are successful and baked. Probably that would be. In fact, there are some. I was following up the discussion. Even there are a lot of unanswered questions to initializers, like about the ordering of initializers, and if, let's say, one initializers depend on another one, how that should be done. So still, I think those questions are being figured out. So let me jump into the demo real quick. So I have a local cluster. I'm using local cluster up, and I have a Kubernetes server up and running. And let me actually I will just reset the state quickly. So I already have, so let me actually, just give me a few seconds. I'm just setting this thing. Okay. So I already have an initializer installed. I'm going to create a pod preset. Let's look at an example of pod preset here. So I have a pod preset named dbconfig. And so first thing it has is what pods that this preset should be injected in. So I'm saying all the apps, all the pods with label matching app is equal to command should get this pod preset injected. And pod preset definition here is that I'm saying only the environment variable, these two environment variables, which is the DB host and DB port. I guess I took this example for Redis, because if you have a Redis application, it will need these two things, your local host and port. So even the default port is of Redis. So we'll create this pod preset. And I do not have this set up with aggregators. So that's why I'm using context service catalog here. So we create this. So this is going to hit the service catalog API server and create this DB config. So this got created. Actually, let me look at the questions here. Okay, this is.
He's just making fun of you.
So we can do, yeah, so we see pod presets are here with these environment variables. Now I'm going to create a pod. Let's look at a pod example here. Command dot. So this is nothing. It's a very simple pod, which is all it is doing is it has a loop, which is it is printing environment variables, and list of environment variables is Kubernetes service host, home, root. And if you look at these two environment variable, DB host and DB port, they are not listed in the containers, and they will be injected by the pod preset at runtime. And the other three are available they are made available by the kubelet itself. So, okay, one more thing to show here is the label. If you see, app is command. So now we'll create this pod, and we should see environment variable. Okay, so this got created. So if we look at what the spec looks like after the creation, so first thing we see is that pod preset was applied, and it's the name of the pod preset is so we add an annotation saying what version of the pod preset was actually applied. And then if you look at, there are two new environment variables that shows up. They were not part of the spec, like DB host and DB port. And if we, let's say, if I see what this guy is printing, it should print, yeah, so it's printing four things. So periodically, so which is Kubernetes host, root, and then the local host and port were actually injected by our initializer. So yeah, that's pretty much it.
All right. Any
That is
questions?
awesome. That is awesome.
Thank you. So yeah, I have these two PRs. They're mentioned in the agenda doc. So right now, these two PRs I have migrated the alpha APIs from core to service catalog. I'm in process of writing a walkthrough. So the first PR, Morgan and Paul has reviewed it. I would encourage everyone to review it and give me feedback. And then once these two are in, I plan to add two small features which are required for the beta APIs, and plan to do that. That's kind of the roadmap.
So what the current API group is moved totally with the same name and everything, right? So it's still settings.kates.io.
No, so I changed that in the PR. It's updated, so now it's settings.servicecatalog.kates.io.
Okay, and have you gotten a sanity check from anybody about whether we're able to claim that namespace?
No, actually, I wanted to figure out two things. One was this namespace, and second, when we, let's say, announce it publicly that it is available to be used, what is the policy for deprecating the pod preset in the core? Because when people are running core with alpha support of pod preset and service catalog as well, how do we want people to migrate to it? That is something that I have not. I will chat with other folks about it. And
here's what I would suggest: is let's put something on the agenda for the next SIG architecture.
Okay.
Which I think is on Thursday.
Yeah.
I am not going to be able to be there, but probably a question to either is there or an API machinery. And API machinery meets every 2 weeks, and they were meeting. Actually, they're meeting tomorrow, I think. So you might ask there, but I expect probably it would be a better idea to ask an architecture, because I know we haven't had this specific thing happen before. As far as what the like backward compatibility guarantees are. I think it's alpha, and so there are no such guarantees. So I'm not sure that we are obligated to keep anything around in core, but we certainly should be as friendly as possible to users so that we don't break them if we can avoid it.
Yes.
All right.
Yeah, I made a note of it. We'll do that. Yep.
Okay. Any other questions, comments?
So another thing that we should consider is whether we actually, never mind. I have to check something out about your PR, Sunil. But I expect that I'll probably have something to add to this, add to the agenda next week about this topic.
Okay. Okay.
All right. Next up on the agenda then. Paul, you want to talk about service class plans or service classes and plans spec?
Well, Nal is here, and he had a demo for CRD, and I wondered if did that make it onto the agenda?
It didn't. No, you want to do that now?
Today. I can demo it tomorrow.
Okay. All right. Yeah, so I think it is likely that we will have some kind of status information that we'll want to show for service classes and plans. And so I created a few issues. I created one to introduce spec, which would, in the sake of preserving young Morgan's sanity, I would suggest that we do after his pull request merges. To introduce spec to service class and service plan. And then I also created issues to have controllers that maintained a count of the number of instances that were on a particular service class or plan. So Doug, I know that you had a question in GitHub. I see your hand is up and that you have self-act. So I will stop talking now until I begin talking again.
Okay. I don't think it really matters much if we wrap these things in a spec or not. I'm just kind of curious. Are you anticipating us needing to create some sort of reconciliation loop at some point on these two objects?
Yeah, I think so. That's what I was referring to by controllers that maintain the number of instances that are on a service or plan. And so what I meant by that was, and I was thinking about this in terms of like replica set, you will have in the status of a replica set the number of replicas that currently exists. And so what I mean by controllers that maintain those statuses is as opposed to when you make a new instance or when you update an instance as part of that transaction script, to quote the Martin Fowler Patterns of Enterprise Application Architecture book, which I'm sure everybody has next to them on their desk. Instead of maintaining that as part of the instance reconciliation, that we should have controllers that periodically maintain, like do a field selection on service instances dot service class name or service instance dot plan name, and maintain the number of instances that are on a service class or on a plan. Does that make sense?
Yeah, I guess. There's part of me that would almost rather wait to have a real need for it. But your number of instances, I think, is probably a good example for why we may need it in the future. But my other question was just more: do you actually see us ever need to reconcile plans and service classes with something outside of our system?
No. And so when I say reconciliation loop and controller, I really mean something that's just maintaining the status.
Yeah. Okay. All right. Any other questions, comments?
Seems to be non-controversial.
Yep.
Okay.
Okay. Hold on. Let me just take some notes here. There really isn't anything. I mean, you're not actually looking for a formal decision right here. You just want to make sure there are no objections being raised.
Yeah. I mean, and if we don't have any objections, I guess we can call it consensus tomorrow, maybe.
Okay. Cool. In that case, Orphan mitigation is up next.
Okay. So Orphan mitigation is conceptually much simpler than I had feared. So to level set about what that is, there's a part of the spec, Open Service Broker API spec, that is meant to prevent resources associated with instances or bindings from leaking. So, for example, if you have a synchronous provision call and that times out, the idea of orphan mitigation, the orphan in this thing is the instance that you might have created or that you tried to provision, which might have been created but you don't know. And basically, when something like that happens, the controller should send a deprovision request and make sure that resources don't leak. So the design for this is pretty simple. I guess let me clean up my my browser here, and I can share my screen. Got a good long shot of my mouth hanging open in stupefaction as I attempt to close browser tabs. All right, so truly incredible. This is so odd. Slack or Zoom is highly inscrutable to me at many times because it will not give you the option of sharing the window that you want to share. Very bizarre. Can people see my screen?
Yeah.
Let's see. Okay. So the proposal is basically to add a field to the status for service instances and for service instance credential. It can follow the same pattern. Slightly simplified for service instance credential because there are no async operations currently. But once the controller detects that orphan mitigation has to be performed, it should set this orphan mitigation in progress Boolean and set the conditions accordingly, and like the readiness condition, and it should start doing the deprovision, and the broker might handle a deprovision due to orphan mitigation asynchronously, just like any other deprovision. If that happens, it should finish doing the deprovision, and then it should set the ready condition to be false and set the failure condition. So for clarity, once you have to do this for a service instance or a service instance credential, that thing is considered to be failed, which is similar. It's how they're treated in Cloud Foundry. So when this kind of thing happens in Cloud Foundry, they consider the instance or the binding to be failed. I believe that if you want to do something with it, you delete it and you make another one with the same name. So it's actually fairly simple. I had feared that there were really complicated behaviors, like if you had to retry to provision after you deprovisioned. But lucky for us, all that Cloud Foundry does is just say, I had to Orphan mitigate this. It might not have worked. It failed. I'm done with it. So Cloud Foundry giveth and Cloud Foundry taketh away. But this one is pretty simple. So I wonder if there are any questions, comments on this one. EOF.
All right, Kibbles, you're up. Michael, are you on mute? Oh, give him a sec.
There's a buzzing.
Yeah, I could hear a buzzing. Is that you, Michael?
Sounds like him.
Okay, so tell you what, Michael, while you work on your mic, let's go on the queue. We'll come back around to you. I think I'm next. So quick question, Paul. Once Orphan mitigation is done, you say you unset the Boolean and everything's fine. And I'm sorry, I tuned out there for a sec, but you started talking about something being set to false. Is that the way we indicate that we don't need to go back and do any other reconciliation again later?
So after you're done, you should unset the Orphan mitigation in progress Boolean.
Right.
You should set the ready condition to false because it's not ready. And you should set the failed condition to true and say, like, give the user some information saying, we're done with this one. The provision didn't work correctly and we had to do Orphan mitigation, or we had maybe something a user's more likely to understand, and say that we've cleaned up to make sure that you're not being charged for any of the resources that you might have created, but it didn't work right. It failed.
And then it's up to the user to go off and actually delete that resource if they want to later, right?
Correct, yeah.
Okay, got it, thank you. Okay, Noel, you're up.
Yeah, so I'm just a little bit concerned that I think this behavior breaks the reconciliation loop. So you just like say, in case of any failure, we just clean up and stop doing retrying. While I think that it should be possible to retry after you finish the cleanup. So why do we stop retrying? Or like if we think that the spec is incorrect, which is not necessarily true, it could be just like network connection failure or something. When we update the instance, for example, why don't we just try to provision it again?
So I think that we could eventually do that, but what I think that we should shoot for initially is something that is simple and easy to understand, that works to ensure that we haven't leaked resources. And if we want to get fancy and do something after we initially support this, that's forward compatible, like if you bump the spec again, we'll try to provision. I think that we could do that, but I would prefer to have something implemented in the short term that would at least make sure that we're not leaking resources. And we can think about whether there's an additional experience on top of that beyond what Cloud Foundry does that we'd want to provide. So in terms of like principle of least surprise, if you're coming from Cloud Foundry, a similar behavior to what Cloud Foundry does is probably what you're implicitly going to expect. And if you're using this for the first time and you don't have context on it already, I think it's okay to just say, hey, it failed, and you can recreate it and try again if you want. Does that make sense?
Yeah, that makes sense. But I still think that it would be available to retry, and I agree that like for a first PR, it should be fine to just stop retrying. But I think we should keep in mind that to be forward compatible with the retrying in future.
Yeah, and I don't necessarily think that I don't think anything about what I've suggested is paints us into a corner, so to speak. So like if in the future we thought it would be good to allow a retry after you had to do Orphan mitigation, I think that we could do something like, if you do that, you bump the spec like you would for an out-of-band change to a secret parameter, and the controller does the whole thing again. Maybe we could do that. And if we did something like that, I don't think that we would have any API breaks.
Right. So I'm still thinking that, like, if you have a connection failure or something, if you have like a network blip, why would you ask user to manually bump it?
Well, now let's put on our programmer hats and split a hair. So if you can't dial the broker, this behavior doesn't get initiated. It only gets initiated when the provision call times out, which could be due to a network blip, right? Like someone unplugged the F5 that runs the edge, and your call timed out. It could happen for that reason. You don't know though when it times out, right? Like anything could have happened. And then the spec also says that you should do this when a provision call gives you back a 408, like the server actually says that something timed out, or any 200 series code beyond 200, 201, 202, or a 500. So it's a fairly limited set of circumstances where you actually do this. But if you can't dial the broker, it doesn't fall into this case.
I'm fine when the explicit error is returned from the broker, but I don't think it is part of Orphan mitigation, right? So the only case when we need Orphan mitigation is probably when it times out, or
the spec has 0.08 in it too.
I think the spec says that it's whether timeout or some completely unexpected status code or something like that. But I might be wrong.
Where completely unexpected is a so if you get a 300 or a 400 series, that's a failure. It means it didn't work. If you get an unexpected 200 series, you don't know. And if you get a 500, you don't know. And if the server told you via a 408 that it timed out, you should do it. I guess, so I'm trying to tease apart what I think is in your head. I wonder, is your concern that the spec is goofy or that this does not match the spec?
I think it probably matches the spec, because I think spec doesn't say anything about retrying at all. So it just says, like, when you do this, it doesn't say how many times you do this and stuff. But
I don't think it even says that you might or may retry. Right.
Yeah. I'm just thinking that in terms of Kubernetes reconciliation loop, it just makes sense to retry at least once, at least a couple of times.
Yeah, I agree with you. And that is what I would do in the absence of something in the spec that told me not to do it. Or rather that the experienced users will probably come to us with will have their muscle memory or expectations be that nothing else will happen on this thing. But we can make it. We can definitely change that in the future, I think, in a forward compatible way.
Okay. So next person on the queue, Michael. Is your mic okay now?
Testing. Can you hear me?
Yes, we can. Go ahead.
Cool. I'm wondering how we deal with like internal failures in the catalog. So say, for instance, during the reconciliation, something goes wrong. We can't connect to the API server, or just the controller goes down, because then we're kind of in a state where we don't know what to do, right? So how do we deal with that?
Very good question. The intention of writing what operation is happening currently into the status before you start working is to prevent situations like that. So that, say that you say, and we're, just for the record, folks, we do have another issue for this that we've already gotten consensus on. What the consensus was to, before you start doing work, record the operation that you're going to do. And then we also have a consensus on capturing, these are the things that I'm sending, and then also to update when you've completed doing some work. This is what the broker knows about. And the intention behind those two things was to make it so that in the event, like say that you update the status and say, I'm now doing this, and you get a conflict back from the API server because someone else has updated the resource. Well, then you didn't do anything to the broker, and you can just return that error and retry with the latest copy. And say that you update the status and it succeeds, and you start doing work, and then somebody sends you SIG kill, and the controller dies. Well, when the controller comes back, the controller can pick up. So I think that like the class of failures that Kibbles is wondering about are these classes of like the controller fell over, or someone fat-fingered the kill command on the machine and killed the controller process, or something else happened. Is that right, Michael?
Yeah.
Does that address your question, what I said?
Yeah. I'm wondering which issue, I guess, that represents the sort of setting the currently ongoing operation on the instance. Is there something, because you said you got consensus for that?
Yeah. Well, I'm still sharing my screen. I'm going to take a look. Oops. Which one is it? 1107?
1147.
Okay. Matthew Stabler says it's 1147.
Okay.
49.
And 1149.
Okay.
Here's
I can.
reconciled instance state. And then I think there's a link into that one about yeah, there it goes. Concurrent updates on instance. So those two are where we discussed it before.
Cool. Thank you.
Okay. So I think I'm next in the queue. So Paul, I just want to make sure that the summary of your conversation with Nal is basically we should be able to handle retries later if we want, because everything you've done here is forward compatible, right?
Yep.
All right, cool. Thanks. Any other questions, comments? I don't think there are any other hands up. Okay. Do people need more time to think about this? We want to revisit it again tomorrow and make sure there's consensus, or do people have enough time already? I think, Michael, based on your question, you may need a little more time based upon the other issues just to think about it some more. Is that true?
Yeah, just a little bit, but I don't want to be blocking if everybody's okay with it.
I heard that Kibbles was going ring shopping for when he gets married to this idea.
So tell you what, why don't we give it just a day? I don't think a day is going to change anything, right, Paul?
I don't think so either.
Okay, so let's give it a day and revisit tomorrow.
Cool. Thank you.
Okay. Next on the agenda, Leon, you wanted to bring up a question about OpenSDS?
Yes. Hello, can you hear me?
Yes, go ahead.
Hello. Yeah. Hello, everyone. This is Leon from OpenSDS. So I guess I have put some questions on the service catalog community, and today I'm here to show you some latest work about how OpenSDS can enable storage service in service catalog. So here we prepare a demo about how OpenSDS can provide safe storage to service catalog user. So do you mind if I share my screen?
Do you think you'll have time to do it and finish in 7 minutes?
Yeah, I think so, because the demo, the video is quite short.
Okay, go ahead then.
Oops. So I guess I can move it faster. So
can you tell us what the acronym OpenSDS stand, or what does SDS stand for?
Yeah, OpenSDS is an open source project in Linux Foundation, and it's a software-defined storage controller that manage different storage systems and integrate into different cloud platforms such as Kubernetes, methods, and so forth. Do I make it clear?
Okay. Yes, thank you very much.
Okay. So in this video, we will show a demo that show our latest work with OpenSDS. So for this video, we have our Kubernetes local cluster and all other stuffs such as OpenSDS and Ceph and ServiceClass are all containerized. Okay, I think we can begin. And so first of all, we can check the initial state of OpenSDS, and the first step is create a OpenSDS broker. Yeah, and after we created, we can show the service class about OpenSDS. Yeah, so I don't know. From here you can see the plant field. There are some field from OpenSDS. The name is default. And next we will choose a plan name to create an OpenSDS instance. Oops, I guess. Oh my God. I don't know if you can see the parameters here. All we need is to specify our capacity. Our capacity is 100 megabytes. Okay. And then you can see we have created a new volume. And after that we will create an instance bounding. So after that we will find a secret called OpenSDS instance secret. Okay. So inside this secret we'll see we'll find some fields generated in the form of base 64 in secret data field. So because there are some base 64 field data to reduce the complex work, we can get them directly from Ceph backend. But if you are using a Kubernetes UI, you can directly get the secret. So in the last step, we will create a WordPress application to consume the storage we have been binding. And we plan about this app. We plan to create a blog server container and register service to use the mounted volume. And in this container, what we want to show is we can create a post in this blog server, and you will find some data stored in this volume. Yeah. I guess this is some register. So we will create a post here. And oh, sorry. we can find some contents inside the volume.
So Leon, this is really cool, but we're running a little long time, and I just want to make sure Paul gets a chance to ask his question because his hand is up.
Yeah, so
Okay.
to use this, you have to know the ID of the Rados volume, right?
Yeah.
That's in the secret though, I think, isn't it?
Yeah.
Okay. I remember, I do happen to remember that from an issue you created on GitHub. That is a cool demo.
Yeah, and the way we solve it is to watch it on the UI. From Kubernetes dashboard, you can directly get the secret. Yeah.
Okay.
Cool.
So we are technically out of time. Thank you, Leon, very much. Is it possible for you to make the URL to that video available so people can look at it offline?
Yeah, I can link the YouTube web link here.
Okay, that'd be great. Yeah, go ahead and put it into the Slack channel because once the meeting's over, we may lose it.
Okay.
Okay, great.
So-
Thank you very much.
Okay, thank you.
Okay, and I think that's it for the agenda. So I guess we're done for today. We'll talk again tomorrow.
All right. See you, everybody.
Okay, bye, guys.
Okay.
Later.